Alrighty, hello everyone. My name is Kit, and today I'll be walking over the Advent of Coding Day 19 problem. Specifically, just the orientation, like how to think about it, ways to visualize it, and how to like actually perform these rotations around the x-axis, y-axis, and z-axis. So let's go ahead and get started. Alright, so for this problem here, we have these scanners, and the way that I think about it is just like a box. So there's these different boxes, and then I usually just think about them as having a specific side that they are facing. So we will call this face, or this side, the facing side. All right, and there can be 24 unique orientations for this specific scanner. Now, how should you think about it? Well, the way that I think about it is that first there are 6 different faces slash sides. Right, if you count the number of sides on this box here, there are 6. And then there are 4 different rotations for each side. Okay, so like for example, say that we are facing, we are at this positioning right now. Another orientation that we can have via rotation is something like this. So this F can be diagonal like this. Okay, another one is that it can be like this. And then the last one is that it can be like this. And then if it rotates again, then it goes back to this position. So here this is like a 90 degrees counterclockwise. Actually, I should have drawn it going, this is 90 degrees clockwise, but I should have drawn it going counterclockwise because we usually think of degrees going counterclockwise. So apologies for that, but I hopefully you get the point. 90 degrees counter or clockwise. CW. Okay, so yeah, that is why there are 24 unique rotations. Cool. Next, I will talk about how to translate the points. So in the description, Eric talks about how for each of these sides, you can think about the coordinate space as being like rotating across along a different axes, and also like flipping and doing that kind of stuff to the boxes. And basically, I'll just show you an example of how I would like translate or rotate a coordinate. So let's just go and jump into an example. So say we have something like this. All right. And this will be the x-axis, and this will be the y-axis. So I'm going to say this is the plus. And then we will go ahead and draw, we'll go ahead and draw our z-axis going out like this. So this is a 3-dimensional plane. All right, so suppose that we have a point that looks like this. Okay, so this would be 4, 4, 1, 0. Okay, and I'm drawing it via x, y, and z. So suppose we want to rotate this coordinate system 90 degrees counterclockwise along the z-axis. how would that look like and how would it affect this point here? So let's go ahead and do that. So I'll go ahead and draw the new coordinate system. So it's going to look something like this. It's going to try to be neat. Okay, so this is the x. This is positive y, and then we still have our positive z-axis going there. And then the point is still at the same position. So still at this specific position. Now, what values should go on here? Well, for z, the z stays the same because all we've done is rotate the axes 90 degrees counterclockwise, right? So hopefully this is just clear from the diagram, but the x went from being here to being up here, and the y went from here to being down, like that. So we've rotated 90 degrees. Okay, so what happens here is that this new y would be in whatever position that we translate it to. And doing it on graph paper helps a lot because you could just see. So this would be like -4. So here for the y position, I would put -4. And this is +1. So here, I'll put +1 here. And this is basically how I came up with the transformations that I noticed. So you can see that going from this transformation, the 1 moves down here. From the previous y, it becomes an x. Then this here moves over here. So this, but it's multiplied by -1. Okay, hopefully that that makes sense. This was like how I kind of figured out the rotations and how it affected the points. And I just did this for like the other coordinate systems as well. So let's go ahead and do another example. All right, so for this one, let's go ahead and do zy. Let's use the same point. So this will be actually for the x, let's be fancy. All right, instead of 0, I'm gonna put a 4 here. All right, and for the y, so we can see here that the y is 1, 2, 3, 4. Then the z is 1. And I'll just rewrite the coordinates or how it's labeled up there for you to see. So say that we rotate it 90 degrees along the x-axis. How would that affect the points? Well, let's go ahead and do that. Like this. Right? So the z is gonna be shifted down here because we rotated 90 degrees counterclockwise. So this will be the new z-axis. Then the y is going to rotate here as well. So this will be the positive y. Then the x stays the same because we are rotating on this axis, so nothing changes to it. Right? And the point stays in the same spot. So if we take a look here, what happened was that for the x, it stays the same because no transformations occurred to it. The rotation didn't affect that point at all. So for the y, it looks like if we just look at the coordinates, this becomes a 1, and the z becomes a -4. Alright, so this turned into that, and this turned into this. This is times -1. All right, so from here we can say that so to rotate some kind of vector, actually let me call this, so rotate 90z. So given a vector, the new vector, vector 3, is v dot x. So the x stays the same. Then let's see what happened. So the v dot z becomes the new y. And then for the new z, it was the negative v dot y. So that's how I came up with this here. Okay, and yeah, that's basically it. So once you get like the rotate 90 for everything, then you can get like rotate 180 and rotate 270 by just like reapplying the transformation. So if you called rotate 90z, this method here, on the resulting vector, it will rotate it by 180 degrees from the starting vector. Okay, so lastly, let's just go through flipping real quick. So flipping is gonna, let's do this with trusty old y and x axes. Okay, so this is z. Oh, I keep erasing it. Okay, so say that we want to flip the x. What does that mean? Well, if we flip the x, then what happens is that we do something like this. So this becomes the positive x now. This is the negative x. This is the positive y. This is the positive z. So let me just put a point here to translate. So 4, 1, 2. Yeah, let's just say that the z is at 2 somewhere, even though I'm not drawing it correctly, but whatever. Okay, so the point still stays the same. The only difference is that since we flipped the x-axis, now this point will be at negative 4 instead of positive 4. It's going to be 1, 2. Cool, does that make sense? So like the y stays the same because we haven't shifted the y at all. The z stays the same. The only thing that changes is this x value here because we flipped the axes. So now the new value must be at this point, must be at the negative x direction. All right, and that's basically all that you need to know for the orientation stuff. So obviously, like the orientation will be used for getting the scanner coordinates in these 24 unique different rotations, and you can do that however you like. If you're interested in how I solve this problem, I'll go ahead and link the code in the description, my GitHub. And yeah, if you take a look at these rotate around methods, then these follow like whatever I just talked about here. Alrighty, thanks for watching. Bye.